Good morning, girls. Today I'm going to do lesson number 24, chapter number 7, matrices. We were doing. Now, in this chapter, we have completed multiplication also. Today, we are going to do determinant of a matrix, and this is important topic. In this determinant topic, we will do multiplicative inverse. That is very important topic. Okay. So all these are actually the steps for the topic multiplicative inverse, whatever we are going to do in this determinant of a matrix. How to find the determinant, then how to find the adjoint, singular, non-singular, and then all we will apply in the multiplicative inverse. Okay, so all are the steps of it. Now what is the determinant actually? Determinant is you can see a number that is associated with a square matrix is called the determinant of the matrix. So we find one answer of the matrix that is called the determinant. Okay. So let me write how you write the determinant. If suppose matrix A is given, okay, let matrix A is given. Matrix A is A, B, C, D. So what we do, we first change this into determinant form. Okay. Now how to change it into determinant form? We write A between these two lines. These two lines are known as determinant. Determinant of A equals to, these two lines represent a determinant. Okay, and we will change this matrix shape into determinant shape. So between two lines A, B, C, D, like this. Okay, so matrix you will change it into determinant form, and determinant of A is equals to, now how to find one single value. So determinant of A is equals to, multiply first and last element. A into D is AD, then minus sign, multiply second and third element, it is B into C is BC. So this is actually determinant of A. You can write it in this sign, and first and last this and this, you can say cross multiply these two and these two. Okay, these two AD minus sign, always put minus sign, AD minus BC. Whatever elements are given, you will always multiply it like this, cross multiply like first and last minus second into third. You will get the answer, one answer, that is known as determinant of A. Okay, you can also write determinant A, this way also you can write. Okay, determinant of A, or you write determinant of A, this form, both are correct. Okay, now how to find the value? You will apply this formula for determinant. For finding the determinant, you will get one single answer. Okay, so that single answer represent the matrix. Okay, I'll give you the example how to find the single value when values are given, numbers are given. So how to find the single value? If suppose matrix A is given, sample, okay, sample number 1, let A, matrix A is suppose 1, 2, 3 and 4. So you have to find the determinant, so we will change it into this determinant form. We will change the matrix into determinant form, first step, and then in the next step you will multiply. How you multiply? First and last, 1 into 4, 1 into 4, then minus sign, you will multiply 2 into 3. Okay, how we have multiplied? First into last, 1 into 4, 2 into 3. Okay, cross multiply, and between them minus sign, So multiply. 1 into 4 is 4, minus 2 into 3 is 6. So subtract 4 minus 2 is minus 2. Sign of the greater number. This is the answer of determinant A. So you'll get one single answer in determinant. Okay. So this is the answer, one single answer that we will apply only in the square matrix. When a square matrix is given, then you can find the determinant. Okay, so easy it is, first and last, and then second and third. Always put minus sign. So this way you can find the determinant. One more example I'll give you. Okay, let's do example number 2. Okay, now example number 2. Let me write the question. Let B is given, matrix B is equals to minus 2, 0, 4 and 1. Now how you will find a determinant? First you will change it into determinant form. B is equals to minus 2, 0, 4 and 1. Now you can find the determinant of B. So it is equals to, multiply first and last, minus 2 into 1, then put minus sign, then second into third. Okay, you'll multiply these two and these two. So 0 into 4. So multiply minus 2 into 1, 2 ones are 2, minus 2, minus sign, 0 into 4 is 0. So the determinant of B is minus 2. So this is the answer. So single value you can find by using determinant method. Okay, it is easy. So first step we have done, how to find the determinant. Okay, now we will find the singular and non-singular matrix. What are singular and non-singular matrices? So let me explain that. And all these actually are steps of multiplicative inverse. That is very important topic. Okay, let's do it. Now singular and non-singular matrix. How to find singular and non-singular? If determinant of A, suppose set A is matrix A is given, so the determinant of A, if it is equals to 0, you know now how to find a determinant. So when you solve it, if answer is coming 0, it is known as singular matrix. Okay, this is known as singular matrix if determinant is 0. Okay, and if the determinant is not equals to 0, second case, if determinant of A is not equals to 0, it is known as non-singular. Okay, non-singular matrix. So these are the two types, singular and non-singular. First you will find a determinant. After finding the determinant, you have to check the answer. If it is equals to 0, it is singular. If answer is not equals to 0, it is non-singular. Let me give you example. Okay, suppose matrix A is 5, 4, 2, 3. This is matrix A, and now we are going to find the determinant and check the answer. So convert it in the determinant form. Then determinant of A is equals to 5, 4, 2, 3. Okay, change it into determinant form. Now you can calculate the value of determinant A. It is equals to, first and last, 5 into 3 minus sign, second into third element 4 into 2. So 5 into 3 is 15 minus 4 into 2 is 8. So subtract, determinant of A is 7, right? Now this is not equals to 0, so it is known as non-singular. Okay, non-singular matrix. Why? Because answer is not equals to 0. According to this case, if it is not equals to 0, it is non-singular. So determinant of A is 7. So it is not equals to 0. So this type is known as non-singular matrix. Okay. Now the second type, if answer is 0, let me give you next example. Okay. Example number 2. Now example number 2. So let matrix B is given. Matrix B is 6, 4, 3 and 2. Okay, this is matrix B. Now you have to find the determinant. Now determinant of B, then determinant of B is 6, 4, 3 and 2. You know the formula how to calculate it. Determinant of B. So first into last, 6 into 2, then put minus sign, second into third element, 4 into 3. So 6 into 2 is 12 minus 4 into 3 is 12. So it means that determinant of B is equals to 0. If answer is 0, so according to that condition, it is known as singular matrix. Okay, singular matrix. So these two types you have to learn, you have to practice. So this, according to this, we will solve the multiplicative inverse questions. Okay, so easy it is determinant, first into last, 6 into 2 minus 4 into 3. So 12 minus 12 is 0. Answer is 0, so it is known as singular matrix. If answer is not equals to 0, it is known as non-singular matrix. So for the MCQs also, you have to learn this, what is singular and non-singular matrices are. Okay. Now next we will do multiplicative inverse. Okay, so in multiplicative inverse we will find the determinant, and if determinant is equals to 0, then you cannot find multiplicative inverse, and if determinant is not equals to 0, then only you can find the multiplicative inverse. Okay, so the important topic, multiplicative inverse. Now multiplicative inverse of a matrix. In chapter 1 you have done multiplicative inverse of a real number, and you know that it is 1, because when you multiply any number by 1, answer comes same. Okay, so here we are multiplying two matrices. Okay, we are going to find not two matrices, but we are going to find the multiplicative inverse of a matrix, not of a real number, but the multiplicative inverse of a matrix. Okay, now these steps you have to follow. That suppose matrix A is given. Okay, so you can find multiplicative inverse of matrix A if it is a non-singular matrix. Non-singular means if answer is not equals to 0. Okay, so first step, which you, after finding the determinant, okay, find determinant of A, and then you have to check that matrix A is a non-singular matrix. Okay, non-singular matrix, then only you can find multiplicative inverse. If it is singular, it means determinant is equals to 0. If it is singular, then you cannot solve it further. You cannot find the multiplicative inverse. Okay, and multiplicative inverse of matrix A is denoted as A inverse, like this. If it is matrix B, you will write B inverse. Okay, and the formula for it, formula which you are going to use for multiplicative inverse. So the formula A inverse is equals to adjoint A divided by determinant of A. Okay, this is the formula which you are going to use. You already know how to find the determinant. If determinant is not equals to 0, then you will apply this formula. If determinant is equals to 0, you will not solve it further. We will apply this formula. I'll give the example from your book first. Okay, now example number 1, it is in your book. Okay. Now example number 1, matrix A is given. Matrix A is 3, 2, 5 and 4. Okay, what you have to do, you have to find A inverse if possible. If possible means you will find the determinant. If determinant is not equals to 0, then only you can solve it. Then apply the formula. If answer is 0, you cannot find multiplicative inverse. Okay, and the second thing we'll do in this is verify, where we'll do the verification also. So how we verify A into A inverse equals to I. You have to learn this part because sometimes they don't give this in the question. They will just ask you to verify. So how you are going to verify it? You will apply this method, A into A inverse equals to I. With the help of this, you can verify the answer. Okay. Now let's find the A inverse, multiplicative inverse. Okay, let's solve it. First step is to find the determinant so that we can check if it is possible to solve it further or not. Okay, so matrix A is given. Let's write matrix A and change it into determinant form. So A matrix A is 3, 2, 5 and 4. We'll change it into determinant form. Okay, then determinant of A is 3, 2, 5 and 4. So this is the determinant form, and you know how to calculate that determinant, how to solve it. Determinant of A is first into last, 3 into 4, then minus sign, second into third, 2 into 5. So 3 into 4 is 12, minus 2 into 5 is 10. So determinant of A is 2. Okay, so this is the determinant. Now determinant of A is equals to 2. Okay, 12 minus 10 is 2. Okay, so the answer determinant A is 2. Now this answer is not equals to 0. It means that therefore A inverse exists. Okay, so it means that you can find A inverse. Okay, Now after finding A inverse according to the formula, after finding determinant of A, now how to find A inverse? In the formula you can see that there is determinant of A in the denominator and numerator is adjoint A. Now what is adjoint A? Um, Let me explain adjoint A first, then I will continue this question. Okay, uh, I will continue this question after explaining adjoint A, then I'll find adjoint A in this question. Okay, uh, let me explain what is adjoint A. Okay, let me explain this first. Adjoint of a matrix, what it is. Okay, adjoint is always you can find of a square matrix. Okay, uh, it is a square matrix. Okay, adjoint matrix is always a square matrix. We denote this matrix denoted by ADJ. Okay, short form we write ADJ, and suppose if matrix A is given, we'll write ADJA. If B is given, we write ADJB. Whatever matrix is given, you will write that matrix name. Okay, now what we do in this adjoint matrix, we exchange the elements of first and last, that is principal diagonal. Okay, first and last elements are principal diagonal, so interchange. Okay, interchange the elements. Which elements? Elements in the principal diagonal. Now what is principal diagonal? Diagonal elements. Now which diagonal elements? First and last. Okay, first and fourth are principal diagonal elements, so you interchange their places, and after interchanging you have to change the sign. Okay, first part is interchange the place of principal diagonal, means first and last elements, first and fourth element, you will exchange their places. Second part is you have to change the sign, change the sign of the other elements. So what are other elements? Other elements are second and third. So change the sign of second and third element. Change the sign means if plus sign is given, you will change into minus. If minus is given, change it into plus sign. Okay. Okay. So how it is written? Let matrix A is given. Matrix A is A, B, C and D. So according to the condition, what we are going to do, we will write A, D, J, A equals to, now change the place of principal diagonal. These two are principal diagonal, so exchange their places. D will go there and A will come in the end. Okay, exchange their places. Then the second part, change the sign of the other elements. Other elements are second and third, so change the sign. Plus B will change into minus B, plus C will change into minus C. So this is the answer. Okay, change the place of first and last element and change the signs of second and third element. Okay, let me give you examples now how to change it. Suppose matrix A is given. Let matrix A is 4, 3, -2 and 7. You have to find adjoint. Adjoint comes in the MCQs. Okay, so adjoint A adjoint A is, change the place of these two, okay, exchange their places. So 7 will come here, 4 in the end, and these two elements you will change their signs. Plus 3 will change into minus 3, minus 2 will change into plus 2. So this is the answer. Easy it is, simple it is. One more example. Suppose matrix B is given. Let matrix B is 1, 0, 8 and 3. So find adjoint of B. Adjoint of B is, change the place of first and last. So 3 will come here, 1 will go in the end. 0 will remain as it is because 0 doesn't have any sign. So don't write plus or minus sign with 0. 0 will come as it is, and minus 8. So this is the answer. Simple it is. So in this step we will use a multiplicative inverse. Okay, let's continue a multiplicative inverse example. Okay, let's continue it. Okay, we were doing this example. Now in this example we have done the first part. You have to find determinant first. Okay, so determinant A is not equals to 0, so it means you can find A inverse. So after finding determinant A, we will find adjoint A. Okay, just now I've explained you how to find adjoint A. So let's find adjoint A. So adjoint A is equals to, now matrix is 3, 2, 5, 4. So exchange the place of first and last, 3 and 4. So what will happen? 4 will come up and 3 will go in the end. Okay, and change the sign of second and third element. Plus 2 will change into minus 2, plus 5 will change into minus 5. So this is adjoint A. Now what we are going to do, we will put the values in the formula. Formula is A inverse adjoint A upon determinant A. So we will put the value of adjoint A, then we'll put the value of determinant of A. Okay, let's put the value and solve it. Let me put the values. So A inverse is equals to adjoint A divided by determinant of A. So put the value. Adjoint is 4, minus 2, minus 5 and 3 divided by determinant of A, it is 2. Okay, answer of determinant A is 2. So divided by 2, or you can change in this form. So separate this 1 upon 2 and into adjoint matrix 4, minus 2, minus 5 and 3. So this is the answer. You only have to find determinant of A, then find adjoint A, put the values in the formula. If you know the formula, you can easily solve it. You will get the answer. Simple it is, it's not difficult, easy question it is. Okay, now the second part of the question is to verify. Okay, let's verify the answer. Okay, verification will do now. Okay, now let's do the verification part. You have to verify A into A inverse. A inverse is multiplicative inverse equals to I matrix. I matrix we have already done in the types. Unit matrix is known as I matrix, that is 1 0 0 1. Okay, now we will multiply these. A into A inverse. A into A inverse means matrix A is the question. Okay, So matrix A is the question. 3, 2, 5 and 4. Multiplied by A inverse is the answer, multiplicative inverse. So answer is 1 upon 2, and the matrix 4, minus 2, minus 5 and 3 equals to I matrix. I matrix is 1, 0, 0, 1. It is known as I matrix. Now we will multiply A and A inverse. Multiply these two matrices and divided by 2. 1 upon 2 means divided by 2. So, and see that if answer is 1, 0, 0, 1 or not. Okay. So this is known as verification. Let's multiply. You have already done multiplication. So if you know multiplication, you can easily solve this. Okay. So 1 upon 2, we will write it here in the beginning. 1 divided by 2 and multiply two matrices. 3, 2, 5, 4 into matrix 4, minus 2, minus 5 and 3 equals to 1, 0, 0, 1. Okay, we will multiply them. Multiplication, you know, row into column. Okay, so 1 upon 2 as it is. We'll multiply row into column. This row into first column, then into second column. First element into first, second into second. Okay. 3 into 4 plus sign, second into second, 2 into minus 5. Same row with second column. First element into first, 3 into minus 2, then plus sign, second element into second element. Okay. What we have done? First row into first column, then into second column. Then now we will take second row into first column into second column. Okay, second row into first column and into second column. First element into first, 5 into 4 plus 4 into minus 5. We are taking this row now, row into column into column. Second row with second column, 5 into minus 2 plus 4 into 3. This is equals to unit matrix. It is same. Okay, 1, 0, 0, 1. Matrix is same. Now solve it. 1 upon 2 as it is. 1 by 2. You can multiply. 3 into 4, 12. Minus into plus minus. 2 into 5 is 10. 3 into 2, 6. Minus 6. Plus 2 into 3 is 6. Then 5 into 4 is 20. Minus into plus minus 4 into 5 is 20. Now again, next one. 5 into minus 2, 5 2s are 10, minus 10. Next 4 3s are 12, plus 12. So this is equals to 1, 0, 0, 1. Now you can simplify it. 1 upon 2 as it is. 12 minus 10 is 2. Minus 6 plus 6 is 0. 20 minus 20 is 0. Minus 10 plus 12 is 2. Equals to 1, 0, 0, 1. Now 1 upon 2 into this means all these elements divided by 2. 2 divided by 2, 0 divided by 2, 0 divided by 2, 2 divided by 2 equals to 1 0 0 1. So after dividing you'll get 2 by 2 is 1, 0 divided by anything is 0, same here 0 1, and this is equals to 1 0 0 1. You can see that these two matrices are equal. Okay, so two matrices are equal, it means that your answer is verified. Okay, so answer is verified. Simple it is. Write the formula A inverse equals to I. Put the value of A, put the value of A plus A inverse, and I means 1 0 0 1. Okay, multiply the matrices. Okay, this is A into A inverse is the answer, equals to 1 0 0 1. Next step, what you'll do, you'll multiply row into column. Always multiply row into column. Row of first, column of second. So row into column, first column, then same row into second column, you'll get this. Second row into first column, and then into second column you'll get this. Then you can simplify it, and after simplifying you'll get the same answer. Left hand side equals to right hand side, it is verified. Okay, simple it is, it's not difficult, just go step by step, then you'll be able to solve it. In the exams now in the exams they'll ask you whatever they ask you. If they ask you to just find the multiplicative inverse, you will just apply the formula and solve it. If they ask you to verify, then you verify it, otherwise no need to verify. Okay, okay, now one more example I'll give you, last one. Let matrix B is given. Okay, 4 minus 3 8 and minus 6. Okay, now this matrix is given and you have to find multiplicative inverse if possible. Okay, find B inverse if possible. Find B inverse if possible. Okay, so what we do, we will find the determinant first. Okay, first step is to find the determinant. So for B inverse, determinant of B means you will change this matrix into determinant form. 4 minus 3 8 minus 6. This is determinant form. Okay, change the question into determinant form. Now find the determinant of B. You know how to find it. First into last, 4 into minus 6, then minus sign. Second into third, minus 3 into 8. Cross multiply this way and this way. 4 into 6 is 24, minus sign means minus 24. 3 into 8 is 24, and minus into minus plus 24. Now in this case, determinant of B is equals to 0. So you can see that this is a singular matrix. Okay, this is a singular matrix. And I told you before also, if matrix is singular matrix, it means that you cannot find the multiplicative inverse. So it means that B inverse does not exist. Okay. So no need to solve it further. You will stop here. Just find the determinant. If it is 0, don't find multiplicative inverse. If it is not equals to 0, then you will apply the formula adjoint A upon determinant A, or adjoint B upon determinant B. Okay. So important topic we've done today we have completed determinant, singular, non-singular matrices, adjoint A, and in the end multiplicative inverse of a matrix. Okay. Now your homework is to do exercise 7.4, question 1 till 4. Okay. Rest I'm going to explain you. Okay. I'm going to send you the solution. If you want to solve it yourself, please try to solve the whole exercise. Otherwise, at least do question 1 till 4. Very important topic it is. Okay. So please do these questions. Okay. I hope you have understood all this. If not, then you can just ask me anytime. Okay, just message me and let me know that you have understood or not. Okay, girls. Take care, girls. Bye.